what this is. This is simultaneously one of the most beautiful things about modern gaming and game dev, and one of the most dystopian nightmares you could find yourself in as a game dev. What is it? What could it be? Any ideas at all? Yes?
Roblox.
Roblox? No, but close. Yes? This is itch.io. Have you ever used itch.io? Played some games on it? In particular, this is itch.io. All of the games are released on itch.io on February 18th, 2021, before 3 p.m. Okay? Hundreds of games release every single day on itch.io. And it's not just itch.io, because actually that's not even that popular of a game distribution website. Can you think of any bigger ones? Steam. Can you think of any other ones?
GOG.
GOG, right? GOG, good old games. Absolutely. Any others?
Yeah, Epic Games.
Epic Game Store. Absolutely. We have itch.io, we have GameJolt, we have Steam, we have games coming out every day on the Epic Game Store. We've got good old games, we've got Humble Bundle, we forgot that one. Every single day, thousands of games come out on these platforms of every type and variety, of extreme diversity too. You can find games for any particular niche you want. Okay, games like Papers, Please. Do you want to play as a border agent in kind of a 60s, 70s era Eastern European country? You can have a game for that. Do you want to play a game like Dream Daddy? Okay, a visual novel dad dating simulator. You better believe there's a game for that. Okay? What about a game like A Short Hike? You want a cozy game? Okay? You want a game that is kind of a bit different than all the action RPGs, the fighting games out there, the first-person shooters? These days, you can find any game you want for any taste, for any kind of experience. It is gaming nirvana. It might not always feel like that, but when you stop to think about it, we really are in a gaming golden age. Okay? And these games, these interesting games up here, they were all made in different game engines. Okay? Papers, Please, a Game Maker game. Actually, OpenFL, sorry. Dream Daddy, Unity. We've got engines and tons of games using Unreal Engine. Okay? All of these engines, very easy to use, free to use in many cases, off the shelf. It is nirvana, okay? But I have a question for you. Would any of these kind of games been possible in the 2000s? 2000s, not that long ago. These kinds of games would never have hit the shelf. They would never have been available for people to play all around the world for basically free. All right? Because here's the thing. Game development these days is ultra accessible. If you have good ideas, there are engines galore, tutorials, communities, downloadable models and packages, scripts that you can make any game idea you want come to life. It really is amazing, but that was not always the case, all right? And unfortunately, the freedoms we enjoy today might not be around forever if we don't do something, okay? Because if you recall, we have a few major game engines that most people use these days, and they've been making some changes. They've been putting the squeeze on, okay? It might not always be possible for people to make any game that they want for free, okay? And so I want to take you on a little bit of a history lesson here. In the 1980s, it was a very exciting time for interactive media. The NES came out in 1986, brought Mario to the United States, okay, Zelda, Metroid, all those great titles. On the home computer front, the Commodore 64 in 82 was making some waves. We got phenomenal titles that we still love today and play and study today. Super Mario Bros., right? Zelda, Metroid. On Commodore 64, we got plenty of good titles as well. Bubble Bottle, stuff like that. I've got a question. If you have an idea for a game or some sort of tool, what would you need to get started if you were living in the 80s? You want to make a game? You exist in the 80s. Lucky you. What do you need to make a game in the 80s? Any ideas?
Probably assembly knowledge and a compiler.
Yeah, you need a lot of knowledge, but you also need approval from Nintendo. Nintendo's only going to let so many games on their console. And they're only going to let games on if you pay a big licensing fee. And it better not have any bugs or crashes. You better be an expert. Beyond that, if you want to make a game in this era, you need to know assembly language. You need to know a very low-level, very difficult, very custom language, very close to the hardware. Very few people have this knowledge. There aren't that many college courses teaching it yet. Okay? And so, by the way, there are no libraries either. So every time you make a new game, you're probably starting from scratch. And there's really not much reuse at all. Pretty much everything is bespoke. There are no internet resources. There is no GPT to ask for help. Okay? No Google. And so, in the 1980s, it's a tough time to be making games. It is an incredible era, and there are lots of really great games coming out in this era, right? We have these titles to show for that time. But I want you to think for a moment about all the stories we never got. Because in the 80s, you needed so many things and so much knowledge to make a game at all. All those missing games, incredible stories we just never got, okay? It's a shame. Very few people got to express themselves in games and tell their story in the 80s. It's pretty sad when you think about it, okay? In the 90s, well, things weren't that much better, actually. Things were definitely heating up, though. The Sony PlayStation 1994, Windows, okay, was making it a little bit easier to create games and have them run on many different hardware devices. Games like Crash Bandicoot were coming out, making a real impact. Games like Civ were a very big deal. Age of Empires. A question, I'm going to ask you that same question. Now we're in the 90s. In the 90s, if you have an idea for a game, what do you need to make that game? What do you need to bring it to life? What are the barriers to entry? Yes?
Computer.
You need a computer, and often, was it a cheap computer?
Probably not.
No. You needed expensive computers, especially if you wanted to make a 3D game. Okay? A question, if you wanted to make a game for the PlayStation, if you want to make Crash Bandicoot for the PlayStation, you need a special computer that only Sony can make for you. You know how much that computer costs? When Jason Rubin, U of M alum, and Andy Gavin are trying to create Crash Bandicoot, sorry, you got to pay Sony just for the opportunity to try. How much did they have to pay Sony for a PlayStation dev kit in the 90s? Take a guess.
$1,000.
$1,000? I wish. Yes.
30K.
$30K? How about $35K? okay? You want to make a game in the 90s, 35 grand, okay? And that's 90s dollars, okay? So someone open up an inflation calculator and tell me what that would be today. I'm actually very curious, morbidly curious, okay? You need a lot of money in the 90s if you want to make a game. If you want to make a game in the 90s, hey, you don't have to learn assembly, but guess what? You definitely need to know C, okay? Not exactly the world's easiest language to learn. And again, there are college courses, there are some resources, some books, but it's not like the internet we enjoy today. Did someone look up the...
1995 to 2025, that's it's about 75,000.
Okay, you're mortgaging your house, maybe, to be able to afford a dev kit. Hope that game works out for you. All right? Crazy. Back in this era, there were so many barriers. But things are starting to change. It's the 90s, and there's this nerd. His name is Tim. His name is Tim Sweeney, and he's working on this new game. Maybe you've heard of it. He's calling this game Unreal. And he's building this really great technology for the game, and he has this inkling that maybe if he built the technology for Unreal, he could reuse it for other games, or maybe even sell that technology. Just a thought. In the 1999, just a year later, Mark Overmars, right here, is thinking about releasing an animation program he's whipped up. It's called Animo, and it looks a little bit like this. The idea is that you can make objects move around, not by programming, but by clicking and dragging a few little tablets, some icons to move things. Later, he would rename it to Game Maker in 2000, okay? And what's really interesting about Game Maker is that it's free. You can just download it. No big deal. He is quite a generous guy. Mark Overmars is, okay? So there are some interesting little seeds being planted. In the 2000 to 2010s, game dev is really becoming a very big business. The market is beginning to get absolutely massive. It's starting to encroach on the numbers you see from the film industry, from the music industry, okay? Suddenly, big blockbuster games like Call of Duty are making millions upon millions of dollars in the first 24 hours of release. This is becoming a big, big business, okay? Big companies like Electronic Arts are springing up left and right and making a really big go of it. And suddenly, we're starting to see products in the space that aren't games themselves. We're starting to see technology available for sale. Unreal Engine, which spawned off the code base of Tim Sweeney's Unreal back in the day, decades ago, is now available for, $500,000. Okay? $500,000, well, at least it's an option, right? But this was the era where if you wanted to get your game out there, what was one thing you had to do? You had to find a publisher, a publishing company who would take most of your profits, but they would give you the $500K you needed to get the engine you wanted. And they would negotiate with GameStop and Best Buy. Amazon, was kind of a thing, but not a huge thing. If you couldn't get onto the retailer shelves, you couldn't sell your game. The barriers of entry are being chipped away at, but they're still there, okay? Game Maker is free and pretty awesome, but it is small. It can't do that much, okay? Suddenly, in 2005, there's this really strange Macintosh-only game engine called Unity. And it is free, and rumors on the street is that they're coming out with a Windows export version, okay? And actually, it's 3D. It's pretty impressive. It's pretty great. Unity hits the scene, and the fact that it's free and also 3D is a huge deal. They also have a really interesting model for making money. They are going to charge you a small fee to remove the splash screen if you want to. And you get a few extra features for that small fee. They also, if I recall, are only going to take a tax, a royalty, on your earnings. So if your game doesn't make much money, they won't take much money from you. All right? Very nice, very generous. It allows indies to start springing up. Also nice, it is industrial grade. It is fantastic. It has good enough 3D, and it has a lot of targets. You can make a Mac game, you can make a Windows game, you can make a Linux game, you can make games for consoles. All of this from a single code base. Absolutely amazing, okay? It is easy to use. It uses the C# scripting language. Back in the early days, it gave you a choice, actually. You could use JavaScript, or you could use a Python variant called Boo as well. So kind of neat. It also allowed you to easily share assets across projects, or even with other companies, via packages and an asset store. It had a great community as well. Due to the incredible license of Unity and the fact that it got very popular very fast, suddenly universities are using it, which means companies are using it. It starts to dominate the mobile space. Suddenly, Unreal Engine and other engines are forced to change their license. That $500,000 upfront fee, it's gone, okay? Suddenly, all the engines are moving to this kind of we make money when you make money approach, this kind of tax approach, okay? It became royalty-based. They don't make money until you do. And suddenly, this led to an explosion in experimental projects. These kinds of games are much, much harder to make in the 80s and 90s versus in modern times, in part because of these incredible game engines and the licenses that they have with them. Really impressive stuff. What's more, suddenly you find Unreal is coming up in architecture circles. What? It's coming up in film circles. Suddenly, everyone has heard that The Mandalorian TV show was filmed in Unreal Engine, a game engine. What on earth is going on? Absolutely incredible stuff. You're seeing game engines be used in a lot of things, from film to architecture to XR to even national defense. It's kind of crazy. And these engines, right? These barriers, the expensiveness, right? The expensive dev kits, the difficult technical ecosystem, forcing people to program in assembly or C, all right? The monopolized distribution. You're not selling anything unless you can make a deal with GameStop, who's going to take, 25% of your revenue. All of this, these barriers got knocked down one by one. Okay, these days, you can make games on a Chromebook. Okay, not super heavy games, but you can do it. We have these nice game engines with nice scripting languages, Python, JavaScript, C#. It's so nice. And all of these tutorials and asset stores to help us get going. And it's all free. And GameStop, have you seen GameStop? Like, have you been into a GameStop lately? It's kind of sad. Okay, that company is not long for this world. They're selling more plushies these days, it seems, than they're selling games, because there are countless digital stores now where you can get games, you can host games cheaply, you can download them cheaply. It is gaming nirvana in many different ways. Okay? It is an incredible improvement that we enjoy in 2025, but it is a very vulnerable improvement, because do you know what Unity did in 2023? They made a big misstep. They kind of shook game development to its core in 2023. For the longest time with Unity, you download Unity, you grab a personal license, and until you are making money, you don't owe a thing. But in 2023, Unity had a problem. Unity is a public American company, and they have a stock price they have to watch. They have investors who have given them lots of money, and those investors, myself included, kind of expect a return. Okay? And so what does Unity have to do? What do they have to do?
They have to increase shareholder value.
They have to find a way to make some coin. Okay? And Unity has not been very good at this. Unity raised a bunch of money, over $1 billion in an IPO, and now they got to start showing that they can make some money. So Unity did this. They introduced a per install fee, which means if you are using Unity in the future to make your game, then if too many users download and install your game, you have to start paying a fee. I don't care if you're making money. Pay up right now. For experimental games like Papers, Please, for free games, what do you think that does to them? Imagine an indie developer who just wants to make an interesting game, releases it, and then, oops, 1 million people just downloaded it. What happens to that poor person?
They have to pay you a ton of money, so it pushes them away.
They have to pay a ton of money that they don't have. You just annihilated your most vulnerable indies, okay? Sorry, I guess Unity isn't available to you anymore, all right? These game engines, these technological marvels that are the foundation of so much of our media-rich interactive world, from film to architecture to game dev, can be taken from us in the blink of an eye. Okay, we are standing on shaky ground right now, and we're only a couple decisions from some desperate CEOs away from losing access to these things or having these things curtailed or limited hard. Okay, game devs say Unity's new install fee is a threat. They say it because it was. All right, there was a revolt. Unity backtracked, but they still have bills to pay. Okay, they still have bills to pay. In 2021, when we got this data on market share, I think these are Steam releases. This data is brought to us by Thomas Bildeau. Unity dominates releases. Unreal is kind of behind them with some of the bigger AAA releases. And you see that little red dot right there? You see it? I wouldn't blame you for not being able to see it. By the way, if you can't see anything, you're welcome to move closer to the screen or watch the Twitch stream right in front of you. That little red slice right there is open source. That's all it has. That's all Godot has right now. Our main big open source engine. That's it. Okay? Until game engine architecture is public knowledge, open source engines will never be able to compete. They won't be able to provide a strong alternative to these for-profit engines that we currently rely on so much, that we could lose at any moment. It is an imperative that we, as a public, people, know how to make game engines from scratch if we have to. We have to understand how game engines work. We can't let this be proprietary, for-profit only knowledge. We have to get it out there. And if necessary, we need to be able to contribute to public game engines like Godot to make game engines free for everyone forever. That's what we got to do. This is where we come in. This semester, the mission is simple. We're going to start from scratch with C++. We're going to build ourselves a real deal game engine. We're going to start from text adventures. We're going to move our way up into the world of 2D. We're going to then make things expressive. We're going to move out of a grid world. We're going to move to continuous worlds, collision detection. We're then going to take a crazy step. You are going to make your first ever multi-language program. It's going to be Lua on top of a fast-paced, high-performance C++ core. You're then going to integrate the open-source physics engine Box2D. Have any of you played Angry Birds? That's the one, okay? Same tech. And then we're going to go further. We're going to learn about some other things as well. We're going to do data-oriented design. We're going to make super high-performance game engines. We're going to do a particle system. We're going to learn how to do all these things, okay? Because we do not want this knowledge to be lost. We don't want it to be locked up behind a paywall, okay? We're going to defend 30 years of game engine progress by figuring out how to make these game engines ourselves so that in the future, there's ample supply of game engine talent and so that you know how to do all these things, all right? It can't be held hostage anymore, okay? And I think it's going to be really, really fun doing this. It's going to be a great semester. Who on earth are we? All right. Who is this guy up here talking? Max, who are you?
You want me to come up there or stand?
Yeah, whatever you want.
Oh, perfect. I'll come up there. All right. Hi, everyone. I'm Max. I'm the IA for this course. I'm a senior in aerospace engineering and computer science. I took this course last winter, and out of all the classes that I've taken here, I have to say that this one has probably been my favorite. So I unfortunately bugged Professor Yarger probably once or twice a month trying to get the IA position for this class because I absolutely loved it that much. In the last year since I took this course, I've made, I would say, about 1.5 engines. You can see down here, ion engine. You can see it a little bit to the right. That's the engine that I made for this class. I went with a graphical user interface as my extra add-on to the engine at the very end that all of you guys will have a chance to do and do your own thing. The second one is called ArcJet. It's one that I'm currently working on that's more data-oriented, which is what we were just talking about. And then I'm also aiming for it to be 3D rather than just 2D. And then I have a list of all of the software that I'm currently familiar with, which will come more prevalent in this week and next week, and then some of the games that I'm interested in. But I look forward to working with all of you this semester, getting to know you, and then hopefully helping to make this your favorite course as well.
Thank you. Thank you, Max. Max said this is his favorite course. This is my favorite course to teach. I love this course. It is a course that is very low level. At the same time, it's very interactive. You're going to get vastly better at C++ and at bringing other things into your C++ projects in this course. You're going to be learning a lot about the different operating system environments you build in. You're going to become very good at Visual Studio, Make, and Xcode because your game engine has to be multi-platform. If you want all the points and homeworks, you need to make it work on Windows, Mac, and Linux. You're going to learn a lot as you try and accomplish that. Anyway, so what I want to do today, our mission in this 90-minute block is I want to introduce this course to you. I want to illustrate our mission, what we're going to be doing for the next 15 weeks. And I want to give you a feel for whether this course is a good fit for you and your interests and your goals. Okay? I think there's an immense amount to gain through this course, but it is a little bit of a heavy course. So we're going to talk about that and whether it's a good fit for your schedule. Okay, some quick announcements, and then we're going to talk about what exactly this course is, okay? One of your first objectives in this course, I kid you not, it's very simple. It's going to be to log in to the EECS GitLab server, okay? All you have to do is you go to gitlab.eeks.umich.edu, you just punch in your web login username and password, and boom, you're done. Okay, what this allows us to do is it creates your account on the GitLab, and then our auto grading system can find you, can generate your course repo for your assignments, and you'll be able to, when we get to the auto graded C++ assignments in 2 weeks, you'll be able to start very quickly with that stuff. So please log into that. It's just a few seconds to do that. I put it on the schedule right here. The course Piazza and Canvas site are up. You should make use of the course Canvas site. It has everything that you need to know. This Discord is usually pretty lively. You are very welcome to debate and discuss homework assignments on the Discord server. Recordings in this course, all of our lectures are recorded. They're streamed live on Twitch. You can enjoy them at any time, review them whenever you want to. And we have stuff like the AutoGrader dashboard up here as well. They haven't been running for a while. All of them have been turned off just to save some power, I guess. But they'll be back alive pretty soon. We'll talk about AutoGraders when the time comes. One important thing to know for this week is how to read the schedule. This schedule is super important. It will help you understand exactly what's happening in the course and what you should be thinking about and working on at any given moment. If you haven't seen one of these before, here's how you use it. You move your eyes to this leftmost column. You move your eyes kind of down the column, and then you find today's date. It highlights in red automatically for you. Move your eyes right. If you hit a lecture document, then you can see exactly what we're doing that day. You can revisit the slides. You can see any notes, any downloads we might have for you. If you keep moving your eyes right, you might hit the reading, which we may or may not have for you. When we get to a certain day, you will get the hyperlinks to come online. The hyperlinks will show up. You can click on them. If you keep moving your eyes right and you see a green bar, a green block, that means something is launching that day. An assignment is releasing. And if you want to know what that assignment is about, what you have to do, you click on the little button, the little hyperlink, and boom, you have access to whatever you need. Okay? So you can find out exactly what your, actually, wait a second. This is the first reading. This is not an assignment. So this is not an assignment. Just read it if you want to. The readings are optional, but they might help out. If you see a green block under the assignment columns, you can click on the green block and you will get the homework specification. So you'll see exactly what you need to do to get all the points on that assignment. If you move your eyes right and you see a yellow block, what does that mean? That means something is in progress. That means you should be working on something. And if you want to know what, you just move your eyes up until you see the green block and boom, you know what assignment you're on. If you move your eyes right and you see a red block, that is the deadline. In this course, deadlines are on the day and at the start of class. Okay, so the moment we hit 4:30 p.m. EST, that is now going to be considered late if you submit something then. Okay, so you want to get things in before then if you can. I think that's all you need to know for now. One big thing to look at is this course has quizzes. In fact, I didn't really want the quizzes, but I had to have them in order for this to count as upper level CS credit. Okay, this first quiz coming up next week on Wednesday, it's a gimme. Okay, it's easy. These are open book quizzes. They're 20 minutes apiece. They're 20 questions. You're going to have to move fast, all right? So you want to know kind of where things are. You don't have to have things memorized, though. But next week's quiz is going to be on the syllabus, on course policies, on some of the basics of the course, okay? So don't worry about that one too much. What else do we have for you? I encourage you to read the course syllabus when you have some time. It's not super long, and there's some interesting things in there. Office hours are beginning today. And my goodness, for just a 2-person team, we have a ton of office hours for you. We have office hours Mondays, Wednesdays, Thursdays, Fridays, Saturdays, and Sundays. Tuesdays got left out. Very sad. But to be honest, our assignments launch on Mondays. No one's working on anything on Tuesday, okay? Almost no students begin the assignments until Wednesday. Drives me crazy. I wish it wasn't so, but it is, all right? So there you go. But we have quite a lot of office hours. We have on Wednesday tonight, I'll be here from 6 to 8 p.m. in this room, just chilling. If you want to knock out the first homework assignment, I'll be here to help you do that. But we also have a lot of office hours. A particular note is the 8 to 11 p.m. on Sundays. That's right before your Monday deadlines. So please make use of those if you can. All of these are remote. If you want to get my attention, you might have to @me on Discord, and hopefully I'll see it and I'll join you in the voice chat on the Discord server, okay? Do we have any questions on any of this so far? On Monday, our next lecture, we're going to go deeper into course policies and how the course works and stuff like that. And we'll also jump much deeper into game engines and how they function and what unites them and makes them unique. Any questions? I think many of you have taken a previous course of mine. I see a lot of familiar faces, and that makes me happy in a way I can't really express. How many of you have taken one of my previous courses? Oh, that warms my heart so much. It's great to see you again. All of you who are taking this course, you haven't taken a EECS 494, you haven't taken 298, that is no problem at all, okay? You do not need to have any game engine experience at all to do well in this course. It will make the first couple lectures maybe a little bit slower, but the lectures are designed, the homeworks, the first couple homeworks a little bit slower, but they still shouldn't take too long. They shouldn't be too stressful for you. And the lectures and the homework assignments themselves will guide you through them, okay? So there won't be too much friction. Okay, what I want to talk about today is I want to talk about what this course is and kind of how it works, what it's going to look like, and what the course is not. Basically, let's figure out if this course is a good fit for you and your schedule this semester. So, this semester, right? What is EECS 498? Well, it is a game engines course. It's a game engines course. We have a few courses on campus that deal in game engines, but this one's a little bit different, okay? In a way that I think you're really going to love. There are a lot of game engines out there. You probably heard of the names Unity and Unreal dropped on occasion. You might have some nostalgic memories of MIT Scratch. Anyone, yeah, fantastic. Or Game Maker or Godot or something like that. When you look at a game engine, it tends to look a bit like this. This is what a typical game engine editor tends to look like, okay? You tend to have an area, often toward the bottom for whatever reason, that keeps track of all the assets that are going to go into making your game. I'm talking the image files, the script files, okay, the sound files, stuff like that. Often, this bottom area represents an actual location in your file system. So you can often right-click down here somewhere and actually say, hey, show me where this is on the file system, and you'll find it, okay? Up here, we have a section of the editor that's trying to help you understand where things are located and how they relate to each other physically. You often have a view area, a 3D view, or if you have a 2D engine, a 2D view, that you can fly around in and see objects in. In this case, we just have a simple cube and a camera and a light source up top, that little icon. But this always comes with a list view where you can find things by name, because modern games have a million things in them, and good luck finding that needle in the haystack as you fly around the detailed 3D viewport. On the right side, in this particular Unity editor, we have where the logic is. We have the inspector. Sometimes it's called the details pane. This is basically where you've clicked on something. Now you want to know more information about it. You want to look into its guts and see how it really works under the hood. Change things. Usually edit the logic of whatever actor or game object you have selected. This is Unreal Engine, and just switching between the two, you can already tell there are quite a few similarities, actually. You know it's Unreal because the viewport looks pretty, as opposed to like Unity's like, yeah. And the viewport, right, just like Unity, it has a bunch of objects in it, actors, we're going to call them. On the bottom, we have where everything is stored, okay, our assets, our images, our textures, our sound files. On the right, we have information about what that object is that we clicked on and how it works under the hood. This is Godot. It's pretty much the same darn thing. You find all these recurring elements. Does anyone know which game engine this is? This is like an obscure one, I think. This is Snapchat Lens Studio. Did you know that Snap has their own game engine team? Now, they don't call it a game engine, but come on. It's a game engine, okay? So, Lens Studio, have you ever seen this one? Now, this one is ultra obscure. This is Facebook's Spark game engine, okay? It's kind of a competitor to the Lens Studio. I don't think pretty much anyone uses it. I think it's like for creating lenses for Instagram or something. I have no idea at all. But you can see all of these game engines, these editors, are united in kind of how they present things and organize things. This is to say that it is possible to study game engines in an abstract sense without tying ourselves too closely to any particular game engine. And that's what we're going to do. You're going to be making your own game engine in this course, and it's going to take some elements from a bunch of different game engines. At the end of this course, you should feel somewhat fluent Not in Unity or Unreal or in Godot or GameMaker, but in game engines in general. Kind of that notion that you learn C++, and then it's relatively easy to learn any other language. That's how you're going to feel at the end of this course. Why do we care about game engines? Well, I want to show you one really cool reason. Game engines, like we said earlier, are showing up in places you might not expect.
While filming this scene for Disney's Mandalorian, the actors could see their surroundings, but the surroundings weren't actually there. All of this is just LED screens displaying backgrounds pre-made in a video game engine.
Compare that with this fight scene from
Avengers Endgame, where actors jumped around in a sea of green, imagining how VFX artists would make this planet look once filming had ended.
The
The Mandalorian is one of the first major productions to choose LED walls over green screens, and the benefits for the actors are just the tip of the iceberg. LED walls make lighting better, filming smoother, and in certain cases cost a lot less than using green screens.
But to understand why the team behind The Mandalorian chose these LED screens, we have to understand just how they work.
Mandalorian showrunner Jon Favreau revolutionized worth it. Along with saving time and money, the team developed a system that allowed artists to make changes and control the world on the day of shooting.
Settings like exposure, colour, animation playback, and fill lighting are available to the filmmakers at a moment's notice. If they want to move the mountain from one side of the virtual set to the other, they can, right there on set. Not only is it helpful for the actor, who no longer has to imagine where that mountain is, but it's a game changer for the director of photography.
Because in the distance, if there is a mountain range that is a story point, then the DP is no longer guessing where those elements are. He can frame up to them.
Right? We talk often in many of my courses about the iterative design process. Well, here you see game engines bringing a faster iterative loop to the world of film. Suddenly, we don't need to spend 5 hours changing a set if we decide that the sky should be overcast instead of sunny, okay? We can go in and within moments we can make changes, right? So a huge game changer for film. If you open Unreal Engine right now on these computers or your own, you'll see this starter page in which, there's a game tab with a bunch of game templates to start with, but what else do you see? Film. Live events, architecture, automotive design, simulation with a big airplane. Game engines have fulfilled their role in making game development possible. Now, the mission is to take over the entire planet, okay? Take over every field, and they're making progress. That's why it's so important that there are open source competitors to them, to keep them honest, okay? Game engines, game technologies are often the starting fuel, okay, the spark that creates really important technologies in other domains. Arcade machines, believe it or not, were kind of the genesis of GPUs, which are kind of a big deal today, okay? Arcades were really, really popular back in the 80s and 90s because that's where you, for some money, could get some time to play games on a very powerful advanced system, which had unique graphics capabilities that home consoles and computers definitely couldn't afford to have, okay? And so it led to the GPU. Game controllers are now used as kind of general purpose human-computer interaction devices. It is always hilarious and a bit morbid to see defense soldiers holding a Xbox controller. I don't really want to think about what's going on that screen too much. Maybe it's just training or something. Anyway, video games are often the origin of very important technologies. So game engines are extremely critical to keeping that going. So we have a lot of game engines out there. On this campus, we tend to focus on two. Unity, which is the main game engine for EECS 494 and EECS 298, 3D art and animation. And EECS 440, the XR course, tends to focus on Unreal Engine, okay? But in this course, we're not going to focus too much on any particular engines. We're not going to study these two too deeply, okay? Instead, what we're going to do is for the first 2 weeks in this course, we're going to study modern pre-existing game engines. But then, after this first 2 weeks, after we're brought up to speed, right, how many of you don't know about, well, you've never really used a game engine before? Anyone? Okay, that's totally fine, right? You're going to fall in love with these things. They are amazing. We're going to spend the first 2 weeks to remind you of what game engines are. What do they do? What do they look like in our modern world? But then we're going off the rails, okay? And we're going to get this course into it's going to become an intense programming course. We're going to make these game engines from scratch. We're going to build our own engine. We're going to start from a hard-coded text adventure game. That is your homework 3. And it's pretty fun, actually. It is very reminiscent of an EECS 281 project. Maybe a bit lighter, a bit shorter, a bit easier than an EECS 281 project. Okay, it won't take you very long. Then, what we're going to do is we're going to say, I don't want to have a hard-coded text adventure game. I want this to be customizable. I want my users, my players, to be able to find my map on disk and be able to edit it. And then when they play the game, the map is different, the characters are different, okay? This GIF right here looks kind of odd. It's like several million actors running around. This is one of your test cases, your performance test cases for homework 4, okay? Making all this work performantly is actually a challenge. Homework 4 is probably your first really kind of, a little bit difficult homework in the course. I think you'll love it, though. After that, we will say, you know what? We can customize maps, we can customize characters and how they work a little bit. We're going to customize the graphics. We're going to enter the world of 2D. We're going to get out of the command line. And have any of you, how many of you have written some C++ code that opens up a window and actually renders some 2D art to it? Not many of you, not many at all. It is a magical feeling the first time it happens. We're going to teach you the famous industry standard SDL library, the Simple Direct Media Layer library, that will make all of this possible, okay? A very, very powerful little library. We will then upgrade our engine so that it is no longer a grid-based, grid-world engine. We don't want to feel like we're just chess pieces on a chessboard all the time. We're going to move into the world of continuous movement, positioning, and collision detection. Collision detection becomes a lot harder once you move into a continuous world. That's a pretty hard assignment. Homework 5 is a little bit of a doozy, but I think you'll enjoy it as well. Then, this is homework 6, actually. Then, my favorite homework in the course by a mile, homework 7, the scriptable 2D engine. If you notice, everything you've seen up here thus far has been the same genre of game, a top-down kind of exploration game, but we will eventually externalize not only the maps and characters of our game, but we will externalize the logic of our game. We will bring the Lua programming language on top of our performant C++ core. The Lua is where we will define our game's rules and logic and genre, and below it in the C++ is where we will build core technologies like collision detection, like entity tracking, actor tracking, stuff like that, rendering. I think it'll be a really interesting experience for you. It's a very, very powerful feeling. Okay, this is when you feel like, wow, I actually have a Unity-style engine now. Okay, very flexible. Okay, it can do really, really crazy things. In fact, these are all test cases. When I'm designing this course, it struck me that, oh my goodness, I'm making these test cases, and each test case is a game because our program is a game engine, right? You get a game engine, and that game engine will be used by thousands of people to make thousands of different games, and each one is a test case. In fact, when Unity crashes, the Unity bug window will show up and go, oh, I'm sorry about the crash, and then it begs you to do something. What does it beg you to do? Anyone know? Yes? It wants you to submit a bug report. It wants you to upload your project to Unity because you have a test case that reveals a bug in Unity. So, if they can get that from you, they're very happy indeed. Okay, they can solve the issue much faster. So, you will make a scriptable 2D engine. At that point, you have true freedom. Your users, your game developers, can do whatever they want. Here's another crazy thing about being a game engine developer. Thus far, in your programming career, you have made software for users, for people who aren't programmers. In this course, your users are programmers, other programmers. So you will spend a lot of time thinking about the act of programming itself. What do people need to be able to program effectively and safely? If I design my APIs poorly, will people use the function wrong, okay, or get themselves into trouble? How do I make sure that my game engine keeps chugging, no matter how crazy my game designer is? All right, if they call my function 1 million times on the same frame, I have to make sure it still works, no matter what, okay? So, we will then move on, and we will integrate the Box 2D physics engine into our game. This is when things start to really feel juicy. You get dynamic physics that are a little bit unpredictable, a little bit chaotic, okay? It's when games feel like they come to life. We will finish off our standardized, auto-graded portion of the course by using data-oriented design to make a very high-performance part of our engine. We will have a particle system that is capable of rendering millions of particles at once and creating really beautiful effects. Okay, and I think you'll enjoy it a lot. The final 2 weeks of our course are very, very nice. They are engine research. You will have a chance to take your game engine, which up to that point has been standardized. It's just like all the other game engines in the course, except yours has cleaner code, right, and fewer bugs, right? But this is your chance in the final 2 weeks. You can actually see the final 2 weeks right down here. Come right down. Okay, boom, number 10, and boom, 11. And these are your final 2 weeks to add whatever custom research features you want to make your game engine yours. Final 2 weeks of the semester, you can add a custom feature. You might choose. We've had students say, you know what? I don't like Lua. So they rip out Lua and they put in Python. Yeah, that is very Sims 4. Okay? We've had people put in C#, put in Python as their scripting language. Okay, we've had, right, we saw with Maxwell's engine, he added additional editor UI and tooling to make the game engine easier to use. We've had students, one of the most popular things to do for this assignment, because it's pretty easy and very fast, is to make a web export for your engine. So that if you make a game in your engine, you can turn it into a web page and play it in your browser. Super, super cool. Very, very fun. You will know how to do all of this. You will have the programming and C++ abilities, the project management and IDE abilities to hook all of this up to figure out what you need to make this work. Okay? That's the level you're going to be at. You could try Android or iOS build targets. I don't think anyone has done Android yet. I think one person did iOS. Some students go for performance improvements by introducing the topic of multi-threading to their engine. Our engines in this course are single-threaded for 2 reasons. Number 1, multi-threading is a beast of a topic. You take 482, you already know this. And we would need an advanced game engine architecture class to tackle that whole topic. Number 2, it's hard to auto-grade when you introduce multi-threading. Why? Anyone know? Yes?
Race conditions.
Yeah, race conditions, right? The idea that we don't really control the ordering of things unless we're very careful when we move into a non-deterministic multi-threading environment, we have to avoid that for auto-grading purposes. I'm working on an auto-grader. Here's a tangent coming at you. If you go to any of my course websites, you'll see all my other courses, and you might see one that's a little bit sus, one that wasn't there before. It's right in this bottom left corner, EECS 498 Live Ops and MMO Architecture. And that is a course in which you will need multi-threading and you'll need networks, both of which are a huge source of non-determinism. How do you auto-grade an engine when the same set of inputs can lead to totally different outputs just based on chance? It's kind of a tough problem, but I'm working on it. And a big problem I'm facing right now, is should this upcoming course be a sequel to this course, or should it be start from scratch? I don't know. I haven't decided. I'm trying to figure it out. Let me know what you think. But anyway, all right, tangent finished. You can decide. We've had students change the data formats for representing scenes and prefabs and objects, templates, in their engine, and they've gotten, 2x loading time performance improvements. Very cool stuff. We've had several students add basic networking and online multiplayer to their engine. Super fun. The students have to actually add and design their own Lua API so that any game designer that wants to use those features of their engine can do so easily. Controller support is one of the most common ways to upgrade the engine. Okay, I'm talking DDR dance pad support in the game engine. Very fun to see those videos of students making that work. Xbox controllers, stuff like that. By default, the autograder will never ask you to implement controller support in your engine. It's only keyboard and mouse, okay, all the way through. But you can add it at the end if you want to. And the big one that everyone always wants to try, and some students succeed, 3D rendering support. In this course, your engine will be 2D, okay? And part of that is because we have a dedicated course for 3D graphics, Professor Park's graphics course. And I think that's a 498 right now. I don't think it has an official number yet. But also because it is a beast of a topic as well, and it will take quite a while to really master that. But you can, at the end of this semester, decide on any improvements you want to make to your game engine. And it's always super fun to see what students choose. We had a student integrate webcam support and facial recognition into their engine, so you could design a game like just using your face, which is kind of interesting. Okay, this is an opportunity to differentiate your engine. Over the summer, I went to China, Beijing, Shanghai, and Hangzhou, and like 3 or 4 of my students from game engine architecture were working in Hangzhou, and they were working in Hangzhou at game engine companies and game companies because they had their own game engine and no other candidates, certainly no students, have their own game engine. Almost no one does, okay? But what's important is that you have something unique about your game engine. Unfortunately, right, some of the local Michigan game studios, they used to be super impressed by students having their own engine, but now they know our course exists, and they're like, oh, your engine is the same as the other candidate who was a student in that same course. Okay, so what makes your engine better than your opponent's engine, right? Okay, you want to have an answer for that. You want to make your engine special, okay? If for no other reason, then we've noticed a lot of students get very attached to their engine by the end of the course, because I think for a lot of you, this is going to be the first time you've spent upwards of 12 weeks with the same C++ code base. The assignments will advance, but if you wrote spaghetti code last week, it's still around this week, and it's still a problem. Okay, so that's another thing we're going to talk about this semester. We will have lectures on code quality and maintenance and try to get a feel for what that actually means in a real deal code base. All right, you have some notion of what clean code means, but we really want to get a good concrete feel for what maintainability means and how to make sure that our decisions this week won't bite us next week. Right? This research at the end of the semester will take place of a final exam. So you have no final exam. Unless you really want one, then I can introduce one for you. Please let me know if you want one, okay? You do have one midterm exam, and I'm not a super big fan of exams, but I was required to have one for this to be an upper level CS credit. First semester, students, no joke, said, Austin, that exam was fun. What? It's not possible. So here's the deal with the exam. The exam designed to be easier than the homeworks, okay? It's kind of a deal we make. The homeworks in this course, pretty tough. There are a lot of them. You're going to want to keep up on it. But if you do, we're going to reward you by giving you an exam that's a little bit easier, okay? And what's more, the exam is designed for 2.5 hours. So it's supposed to take about 2.5 hours on average to finish it. We give you 4 hours, okay? And everyone gets it. So the exam average is usually about an A-, 88% or so, okay? So do a good job, and it won't be a big deal. I really don't like exams. I always felt I would do really good work on the projects, and I mainly understood stuff. And then I'd get to an exam, and I'd just have a bad day, or I'd be sick, or I'd be asked a question that humanity has pondered for like years and years, but I'm expected to figure it out in like 30 minutes. Like, come on. Anyway, we're not going to do that to you. Don't worry. Here is the higher level view of the schedule in this course. We've got 15 weeks to make you competitive for that Blizzard internship. Here's how we're going to do it. The first 2 weeks are going to be kind of chill, right? Exploration. You're just going to be exploring game engines. And you're going to be reminding yourself of why we love these things, how powerful they are, and what kind of different types of game engines are out there. I think it's a pretty fun assignment. We're going to talk more about these assignments because you've got one launching today, and you've got 7 days to do it. I think 7 days to do it. I'll look at the schedule in just a sec. But you're going to have 1 week of exploration and then a second week to kind of cap it off. You're going to be looking at a couple of different kinds of engines, and you get to choose which game engines you want to explore this week. So we're then going to have 9 to 10 weeks of hardcore C++ from scratch development, production of your own game engine from scratch, right? We're going to be going from the text adventure, adorable text adventure game, to a gnarly, crazy, high-performance, multi-language game engine. You're going to do that in about 9 weeks, okay? You will receive a lot of guidance every single week, a lot of lectures to help you out, and the homeworks will help you out too. You will have 1 week of exam preparation. We have several practice exams already available for you. If you're bored, you can just go do them now. It might be kind of tough without the lectures and homeworks, though. But you can check them out if you want to. You'll have 1 week to review the exam, and then we'll have 2 weeks of your research feature, whatever you want it to be, okay? We're very flexible. We grade these 4 assignments very gently. The auto grader is very friendly in its own way, but it's not quite as gentle as the human graders are, the squishy human graders, okay? It's very precise in what it wants. Okay. Yep, research, it should be a pretty fun time. So we say this is an intensive programming course, and we really do mean that. What we find is that a lot of students maybe are very used to building a code base, a C++ code base, for their machine. How many of you are Windows? Okay, you're a PC. Okay, how many of you are Mac? Oh yeah, it's Xcode time, all right? Everyone loves Xcode. How many of you are Linux? Rock and roll, okay, very good, right? So you are gonna build multi-platform engines. That means they have to build and run on every single platform, which means you need to know the build process for all 3 of those platforms, okay? At the very end of the semester, we will introduce a technology called CMake, which is a very cool way to kind of speed all this up. But during most of the course, you're going to find yourself at a Windows machine, at a Mac machine, and at a Linux machine from time to time, getting your project to build and figuring out how these different build systems work. A hint, they're all secretly the same, but the UI is kind of different. So you have to kind of get past that. Okay, most important, impactful game engines these days are multi-platform. Unreal Engine, yep. Unity, yep. Okay. There are 3 different auto-graders in this course, 1 for each platform. So if you complete a homework assignment 100% on Windows, you only got 33 points, not 100 points. Why not? Well, you need to go make sure it builds and passes all the test cases performantly on the other 2 platforms. That gets you the rest of the points. Okay? Should be interesting. I certainly thought it was when I had to go learn these things to teach the class. You will learn how to do some platform-specific logic because some platforms need certain things and certain functions aren't allowed on certain platforms, so it can be kind of interesting. We will have a accessibility and iteration focus in our engines. We will learn how to integrate a second language, a scripting embedded guest language, on top of our host language, C++. It is not as gnarly as it seems. It is very, very cool once you get it working. We'll be using Lua, one of the coolest languages out there. It is a very minimalistic language. It is a legendary language. It allows you to easily configure and make existing software more customizable. Lua is also famous for being a bit annoying when you get started. You know zero indexing, right? Lua is one of the only languages that is one indexed. So you don't start at 0, you start at 1. And Lua is full of other footguns, okay, that will blow you up the first time you use it. But I kind of love it for that reason. It's just an adorable language. It's really fast. It's great. It's easy to integrate. I think you're really going to like it. It's relatively popular still. Okay, what were you going to say?
Yeah, I was going to ask for the auditor system. Maybe I don't have to worry too much about this, but is the Mac built to be on ARM and Windows Linux on x86? Because I'm thinking,
yes,
if I'm having Windows, I can't make the Windows and Linux VMs on here. I don't think that would work too well if it's a different architecture.
Yeah. So the Mac machines are ARM, and the Windows machines are x86 64. So AMD 64, I think. Yeah. The Linux machines, I think, are Ubuntu Graviton processors. So those are ARM as well. Yeah. Okay. So we will be focused on not only accessibility and ease of use, so our game designers have a great time using our engine, but we will also be very focused on having a high-performance engine as well. All of your test cases in this course are performance-gated. You must have a correct output to get the test case points, but you also must complete the test case within, I think, 20% of the performance of the instructor's solution, okay? On some assignments, this is easy. My homework 3 solution is very unoptimized, and on some assignments, this is quite challenging, and you have to do a lot of interesting optimization work to, for instance, make your homework 6 collision detection ultra fast, okay? But still correct. Toward the end, in homework 9, we'll focus on data-oriented design and EECS, which is a really nice way of boosting any system in your engine that is highly parallel, such as a particle system. There are many engines out there that try and boost everything that way, right? Maxwell is kind of working on that right now for his engine. It's kind of a difficult challenge, right? But yes, there will be timing requirements EECS 281 style. Assignments build atop one another. So this is very similar to the old EECS 381 in that you want to do your best job this week because next week you are starting from last week, okay? Last week's work. So this is a course where you don't really want to fall behind if you can. Students have fallen behind. They tend to make it through okay, but it's not a very pleasant place to be. The late policy in this course is unique. If you fall behind on an auto-graded assignment, if you turn something in late, 20% off. But then you can keep submitting as long as you want until pretty much the end of the course. There is an auto-grader off date. It's right after the exam where the auto-graders all turn off and there will be no more auto-grading. So you want to be caught up by this date, April 6th, okay? But, if you need to be submitting stuff for an earlier assignment, like you can do that quite late into the course. 20% off, not ideal. Much better than nothing, though, okay? You can definitely pass with that. Okay, all of this sounds a little bit tough, okay? Intense. This is a relatively intense course, okay? But there's really, really good news. The auto grader is super nice. It is very generous. You can submit as many times per day as you want. It's very fast. It will have results to you usually within a couple minutes at most, and is extremely good at helping you understand what is wrong in your engine. It will point things out to you if it detects some issues in your code base, like you're calling the wrong function here, or you failed to call a function that you should be calling. It will point these things out to you to try and not waste your time. The homeworks are big. Some of them are upwards of 70 test cases. But the auto grader is going to help you fly through them. And oh my goodness, it feels good to knock those down. Okay? When you have an issue happen in your game engine, you will not only get information about what happened, you will be shown footage of your engine running right on top of my engine. And so you'll see that, on frame 427, my code failed to spawn a character in, failed to instantiate an actor that it should have. And that kind of stuff is extremely useful. Our mission is for you to not get bogged down. Have you ever gotten bogged down by a single bug? You're just kind of attacking that thing for like several days straight. That is awful. It crushes your morale. You lose all your momentum. The auto grader in this course, in our experience, is pretty good at helping you not get bogged down. And we have lots of office hours if you do. So you're going to make it, okay? You're going to be fine. There's lots of office hours in the course as well. We already talked about that. In this course, you're going to learn a ton of very pragmatic C++ development concepts. You're going to learn and get much better at C++. You're going to learn things like smart pointers and object pools. You're going to learn techniques like placement new and possibly even some compile time structures via generics and templates. You're going to learn, things that are kind of basic, but a lot of students just don't know coming out of school. You're going to get a very good feel for what static means, okay? Why it's convenient, but why it might get you in trouble. You're going to learn what inline means. If you don't know what that means in C++, you're going to learn a lot about the preprocessor, the compiler, the linker, how they all work together. When your code fails to build, you will know which one of these programs has an issue with what you're doing. And that'll really help you narrow down how to fix it. Have any of you ever tried to build a big C++ project and you're integrating third-party things and it's just like, I can't get this to build. In Python, I just pip install and then import, right? And it just works. In C++, sometimes it's really hard to include other dependencies. That really limits what you can do as a developer in C++. You're going to be very good at bringing things into your C++ project by the end of this course. Very pragmatic thing, okay? You're going to be very strong with Xcode, Visual Studio, and I think a lot of students actually use CLion on Linux, which is a pretty good IDE. We're looking at that one for the MMO architecture course because it's multi-platform. The course standard is C++ 17, which is nice. It has some modern features, not all of the ones that students sometimes ask for, but we'll use C++ 17, and you're going to use a ton of version control in this course. The way that you submit in this course is via version control. You make a commit with a certain Git message, log name, and depending on that name, the autograder will see that commit after you push it, and it will start processing that commit and vetting it. It will clone it down, build it on the autograder, and then a few minutes later, you'll get a nice GitLab comment and an email showing you what your grade is and how everything went. It's pretty cool. It took me forever to make, and it almost killed me, okay? I wish I was kidding. So Git, you cannot submit to the autograder without it, but it turns out to be very nice. if you start running into these weird, hard to debug memory issues after making some changes, you know what to do? Revert. Okay, get out of there. All right, and that will give you a very strong feel for what was causing the issue as well. You can look at the diff. Okay, so knowing all these things will make you a very valuable member of any hardcore C++ production team. I'm not just talking game dev, high-speed trading, any sort of team that is using C++ in like a systems sense or a legacy sense, maintaining old stuff. I remember working at Electronic Arts, and the team members who could help me figure out my build problems were saints on the team. They were absolute saints, okay? They were highly respected by all, and they had as far as I know, they had very, very long careers on their teams, okay? And no one wanted them to leave, all right? So the expected workload in this course is 1 hour to 1.5 hours at the heaviest, and that is every day, okay? So an hour per day of this course will give you a lot of momentum. It will get you through the assignments you need to get through, and it will keep things pleasant. An hour a day goes by fast. It really, really does. Here's the problem with this course, and here's where people run into problems. What happens to this 1 hour a day, 1.5 hour a day requirement if you skip a few days? There aren't that many days in a week, okay? Pretty soon, if you skip a bunch of days, if you get started only on the weekends, I'm going to wait until the day before and I'm going to knock it out, right? That doesn't work so well in this class, okay? Not at all, actually. The course is much easier than it used to be because the autograder's gotten very good, kind of trying to protect you and keep you from being bogged down. But you don't want to get to a point where suddenly you have to spend 3-4 hours a day for the next few days. That is very painful. This course is not designed to have you staying up all night. And if you are staying up all night, you need to let the course staff know. We have a lot of techniques and tips. We've watched a lot of students successfully complete this course. We've also watched a lot of students struggle. And we know how to get you back on track. So please reach out if you start to have problems with the workload in the course. We can help you with habits and techniques and get you back on track. All right? So an intensive programming course, this is definitely one of those. Okay? You're going to get much better at C++ by the end of it. And I think that's part of why I love this course so much. You're going to be a good programmer by the end of this course. Pretty darn good. All right? Pretty darn good. Okay. This is also in some ways an unfinished course. This is a very new course. Not my newest course, but still very fresh out of the oven. Does anyone know what pre-alpha means? Anyone know? Yes, so in software development, there are kind of these stages of progression. And you often hear of a beta, right? Beta. A game is in beta, or a software is a beta version. That means it is known to probably have a bunch of bugs, and you expect to run into them. Well, first, a piece of software enters pre-alpha. That is where the software doesn't have all of its content or features yet. It's just incomplete. You might still be able to use it, but they're going to be missing things. When you hit alpha, you kind of have everything in your software, everything in your game that you're going to have. You've got all the features, all the stages, the maps, the characters, all that, but it's not really finished. When you're in beta, you are trying to polish everything. Okay? Everything is in the game, but you are trying to polish it up, make it nice. You're trying to balance a game, or you're trying to fix bugs that are there. And then once you're out of beta, you have a gold candidate and you are finished, okay? Pretty much finished. You might do some post-release patching and stuff, but that's pretty much it. So when I say this is a pre-alpha course, what I'm saying is, you know what? It's probably alpha because we pretty much have all of our content at this point. I might add 1 or 2 more lectures, but it's almost finished, but not quite there, okay? Why release a course if it's not quite finished, okay? Most of the course is finished, and we need data and real students going through the course to give us feedback to polish it up in a good way and fix things up. The current status is that the assignments are pretty much entirely finished. I need to add some more test cases to a few assignments to help reveal some bugs that are common that students tend to have, but we're almost entirely finished. Data-oriented programming is kind of short. It's the newest one. It's a really fun one. It's not very hard. We might make it a little bit harder this semester. Not very much, though. Don't worry too much. The quizzes are finished. The exam is finished. And it's going really well the last few years. The lectures are mostly finished. I might add one or two more. This won't be an EECS 494 grade experience, but it probably won't be too far from it. When I say this is my favorite course to teach, there's a major reason for that. It usually goes pretty smoothly, and it's very fun. Students learn a ton, a massive amount. There will be a little bit of friction. Some lectures might feel a bit short or incomplete. If you have any issues with assignments, if you think it's ambiguous or you miss something, one of the best things you can do in this course is if you're confused, don't keep it to yourself. There's a bit of a pride thing with this, right? Like you want to keep quiet and you want to kind of figure out the problems yourself. Do that for 15 minutes. But then after that 15 minutes is up, go to Piazza, go to Discord, and ask a question. I learn a massive amount about where the course is going wrong and where it's going right by the questions that students ask. Also, you're allowed to help each other with assignments so long as you don't share code, okay? So long as you are not copying and pasting code from your project to theirs, you're probably good, okay? And I encourage you to go to the Discord server and let me see, where is it? Here it is. Go to that debate and discussion channel and ask questions, okay? Do whatever you want to. Help people out. Post memes. Let me know how things are going, and that helps evolve the course over time. It also helps us really quickly respond to issues you're having so that you don't get stuck for 5 hours, okay? I'm going to be sitting here in office hours just kind of rotting away because not a lot of people come to office hours, especially on the Mondays, okay? And so I need something to do. Ask a question on Discord, and I'll try my best to answer. I am a gameplay engineer by trade. I am a bit of an engine designer and developer, but not a master one. I will try and answer any questions that you have, but my knowledge isn't entirely complete on the topic either. All right? The difficulty curve may be slightly odd and changing as we move on. I think it's actually really good now, though. And a great thanks to all of you for helping us improve the course. If you have thoughts on the course, let us know, please. I always appreciate it. From 494, you know that feedback is a gift, and I very much believe it. You tell me the course stinks, I'm going to be salty for a day, and then we'll figure out how to make it better, okay? So I appreciate it. What this course is not, okay? This is not a dedicated 3D graphics course. We will go into some topics in 3D graphics. We will talk a little bit about matrix transforms, the classic transforms that you see in 3D graphics. But we have a dedicated course for this topic, and it is a pretty vast topic, so we would need a sequel course to do it. We already have a course for it, though. This is not a physics course, okay? We will be learning a lot of interesting concepts that relate to physics engines and how to integrate them and employ them, but we won't be getting onto the whiteboard and grinding calculations ourselves, okay? Maybe that's a really big positive. Maybe it's not. I don't know. Whatever you want. This is not entirely finished, but actually this is not correct for this semester. The course is almost entirely finished. We'll be making adjustments as we go through it. And this is not an easy course. This is a formidable course. All right, I would describe this as probably around EECS 485++, a little bit harder than that course, probably notably easier and lighter than EECS 482, but it really depends. It depends how interested you are in the homeworks, how much the material grabs you. A lot of students start making game dev stuff, technologies or games themselves or engines, and suddenly the whole night is gone. You got too into it, enraptured in this topic, okay? And for better and for worse, right? We don't really want you programming all night. Sometimes you get into the flow state. Have you ever felt that? And it's so hard to stop, okay? I vote when you get into the flow state, you roll with it. the amount of knowledge you'll gain during that flow state period, those few hours, is going to be incredible. It's going to be vast, okay? And you'll feel very good doing it as well. Okay, I recommend 1 to 1.5 hours a day. If you do that every day, you're going to fly through this course. You're going to learn a lot, and you will get lots of sleep. Sleep like a baby, okay? If you can team up with a partner, there are no partner projects and assignments, but as long as you don't share code, you're good. And meet up. Treat it like a workout buddy, okay? Keep you honest, keep you disciplined. Knock out an hour or two every day, and suddenly this is much more manageable, okay? All right. And I hope that, I hope you will enjoy this course. This course, building this course gave me more confidence in my own engineering abilities than anything that I've done in my entire career. This engine is available online. I don't advertise it much, but it is perfectly usable for making your own fully functional games. Toward the end of the course, your test cases will be fully functional games that you can play just for fun. Download a test case, play it. You've got your own little game I made for you. Took a long time, but you will have that same confidence when you finish this course. Okay? You will have been through it. You'll have a big, genuinely big C++ code base that you've been with for several months straight, that you have a lot of stories from. Okay? A lot of bugs you can talk about in interviews, a lot of interesting build issues for when you had to fight Xcode tooth and nail to get it to do something. All right? And you will start to see that all of these crazy issues you run into when you're dealing with C++, they all kind of make sense. They're not the big deal that they once were in your head. I remember when I was a kid wanting so badly to be able to make big projects, do interesting things in C++, and I always got thwarted by some random build issue, some nasty error my IDE was spitting out that made no sense to me and no one could help me. And that just doesn't happen anymore, okay? Those issues are gone. And if that sounds like a good time to you, a fun place to be, that's where you will be, okay? In, 12, 13 weeks, okay? I think it's going to be a great semester. I love this course. I hope you will too. Please let me know if anything comes up. And if you have any questions or comments on this course, please let me know. Please meet each other. Please talk to each other. Don't be afraid to reach out on Discord. The more immersed you are in your community, your fellow peers, the easier this course is going to be, the more fun it's going to be. This is not a zero-sum course. This is not a curved course. Okay, I will give A+ to each and every one of you. I should. Making a game engine that runs at all is a miracle. Talk to students at any other university. You won't find courses like this. You won't find students like you. Okay? You got a lot of guts taking this course, and I really respect that. Good for you. All right, everyone, I hope you have a fantastic start to this semester. Have a fantastic day today. And Max, you got something?
Yeah, just have one quick thing to add. It was talked a lot about during this first official lecture that you have to make.
Ladies and gentlemen, really quickly, something from Max.
It was talked a lot about that you have to make your engine work on 3 different platforms, that being Windows, Linux, and Mac. And if you're worried about not having access to any of those 3, I don't think it was explicitly mentioned. All over the Userstat, there's different computers that run all 3, especially right across the hall. There's Macs that are open for use all the time.
Yep. On Monday, we'll talk about logistics. Bottom line, we got everything you need on this campus. It's not a big problem. Okay? All right, everyone. Take care. Have a good night. And we will see you next time. My office hour starts now for the next 2 hours. I'm going to be right here. Hey.
I have a question about the lecture slides.
Yeah.
Do you usually post them like before lectures?
Yeah. So the lecture slides show up on the calendar. Mm-hmm. Okay. On the syllabus, you can actually gain access to a lot of this stuff way early. It's kind of hidden. But in general, I post the lecture slides and the assignments as we reach them. And this is done to kind of protect the student from making bad decisions, and also to kind of control the pacing of the course. And so, if you want to go, if you want to go early, there are ways to do it. I'm not going to tell you. I would say all of my lecture recordings are on YouTube, which means previous semesters are on YouTube, which means links to documents are on YouTube.
Oh, I see.
But be careful, because the requirements for the assignments actually do change from semester to semester, and the autograder changes. The dependencies can change. So my advice would be, like, if you have extra time, relax. Go enjoy experimenting with other game engines, or go to Wolverine software or something, right? Or just chill, because they're going to be tough moments in the course. You want to be well rested for those, especially homework 7. It's so good, but it's like a 2-week homework. It's one of our few 2-week homeworks, and you need you need that every day.
So would you say that previous lecture slides from previous semesters are kind of outdated?
What happens is when we reach a lecture, I usually update things. Usually, you're not huge updates.
Right. Thank you.
You're welcome.
Hello. Hi. I was just wondering, what's stopping me from using VS Code for every single operating system?
You can do whatever you want. The autograder is going to have a few requirements. I need to quit the stream as well. Everyone watching the stream, take care. Good to see you. We'll see you next time. Bye-bye.